Release 170 is moving towards us with a speed of 14 kilometers per second. Now the question rises, how do we even measure the speed of a star which is millions and trillions of kilometers away? The answer is by analyzing its spectrum. Let's find out how. Light is made up of different wavelengths and different frequencies. So when we split out these wavelengths, we are going to get this continuous spectrum from having longer wavelengths to shorter wavelengths. Well, something interesting happens when we pass this light through a gas. Certain frequency of light gets absorbed and they result in this discontinuous spectrum, which we call it as absorption spectrum. By analyzing the absorption spectrum, we are going to get a lot of data like the star's density, temperature, but now let's understand the translation motion of a star, which means whether the star is moving towards or away from you. Well, my question is, does the translation motion really affect the spectra? Let's find out. So let us consider we have a stationary star which is not moving. It's gonna have a normal spectrum, and let's consider it has wavelength like light. So what if the star is moving towards us? Its frequency increases and wavelength decreases. Ooh, that's interesting. And this is called as the Doppler shift, where the light speed is constant, but whereas the frequency actually increases. So what happens to the spectrum? Well, the spectrum is shifted towards blue, so we call it as a blue shift. And now you can quite guess it. What happens when the star is moving away from us? Its frequency decreases and wavelength slightly increases. And what happens to the absorption spectrum? Well, the lines are shifted towards red. So this is called as red shift. And now the story comes to an end. By measuring the Doppler shift, we can know what is the velocity or relative velocity of a star. Thank you.